In this example, we're considering the market for sweatshirts. So I'm going to start by drawing our supply and demand model with quantity on the x-axis, price of a sweatshirt on the y-axis, the upward sloping supply of sweatshirts, and the downward sloping demand for sweatshirts. And I'll go ahead and label our reference point where we start at is equilibrium. And then we're going to consider separately 4 different scenarios that will impact this market in some way. So the first scenario is 3A. There's a hurricane in South Carolina that damages the cotton crop. Well, cotton is a major input into the production of sweatshirts. So when that input gets disrupted, it's going to become harder to get cotton. It's probably going to get more expensive. And so the marginal cost of producing a sweatshirt is also going to increase. So in order to demonstrate the rising marginal cost of production in the sweatshirt market, we're going to shift up our supply curve. We'll call it S2. And now we'll see that at our prevailing market price, P star, we're out of equilibrium. So while the demand curve didn't move and so quantity demanded stays here, quantity supplied is now going to be lower, QS. And so we're going to have a discrepancy. We're going to have more being demanded than is supplied. So there'll be a shortage in the short run of sweatshirts. What does a shortage do to the price of a product? It tends to drive up the price, and so as sweatshirts become more expensive, we're going to see some consumers cut back on purchasing them, so we have a decrease in the quantity demanded. At the same time, though, some producers will be able to make more sweatshirts profitably because despite the higher cost of making them, the price is now higher that they can be sold at. So the price will stop rising once it's achieved P star 2, where quantity demanded and quantity supplied are back in balance, back in equilibrium at Q star 2. So the overall effect here is that after the cotton crop is destroyed, or damaged rather, the quantity of sweatshirts bought and sold will be lower and they will be more expensive per sweatshirt. In scenario B, we have that the price of a leather jacket falls. So what would be the impact in the market for sweatshirts when that happens? So let's again draw our supply of sweatshirts, our demand for sweatshirts, our equilibrium before the change, Q star, P star. Okay, and so now what happens when leather jackets become cheaper? Well, we can think of leather jackets as substitute leather jackets and sweatshirts are substitutes, so you either wear a leather jacket or you wear a sweatshirt. So if one item gets cheaper, people will buy more of that and less of the other. So in this case, people will end up buying more leather jackets and fewer sweatshirts. So the demand for sweatshirts falls to D2. All right, and now at the prevailing or original market price, P star, we find ourselves out of equilibrium. So the supply didn't change, so quantity supplied is still at Q star, but since the demand curve shifted in, at the original P star, the quantity demanded is now lower. So we have more supply than demand. In other words, we have a surplus or an excess supply of sweatshirts. So this is going to drive down the price of a sweatshirt, right? People aren't buying as many. The stores can't move their inventory, so they're going to have a sale. Buy one, get one free on sweatshirts, 20% off on sweatshirts. That's going to get some consumers in the door buying more sweatshirts, but it's also going to reduce the production. So quantity supplied will fall as the price that sellers can sell at is no longer as high. Eventually, the price will stabilize once the surplus is gone. So that'll happen when we get to P star 2. And again, that's where quantity demanded and quantity supplied will be once again in balance, equal to each other, or in equilibrium. The third scenario, 3C, says that all colleges begin to require morning gym class in appropriate attire. So we're assuming here that sweatshirts would be appropriate attire. So what would be the impact on the market for sweatshirts? So let's start again with our initial equilibrium before the change, and then see what the impact of this new gym class requirement is on the market for sweatshirts. So obviously students are going to be buying more sweatshirts, so demand for sweatshirts will increase, shifting out to the right to D2, right? And now at the original market price, we'll be out of equilibrium. The supply is still where it was, but now the quantity demanded is higher. So there will be a shortage in the short run. Not enough sweatshirts to go around. So this will drive up the price of a sweatshirt. Lots of demand, not enough supply in the stores. So sellers will start raising their prices, which will actually get some buyers to buy fewer sweatshirts, right? Consumers do not like higher prices, but producers do like higher prices, and now they'll be incentivized to produce more. Eventually, the price will stabilize at P star 2 once the shortage is gone, and there's no more pressure of a shortage to drive the price up. So that'll happen at our new equilibrium, Q star 2, P star 2. Okay, so overall, the impact is more sweatshirts being bought and sold, and the sweatshirts are actually more expensive per unit. The final scenario, 3D, says that there's a new and improved knitting machine invented. So presumably, since it's improved, that means it's going to make it easier, faster to make sweatshirts in the market for sweatshirts. So here's our supply of sweatshirts, our demand, our starting point before the new machines are invented. And now we're ready to assess the impact of this new innovation. So if these machines are new and improved, they're going to make it cheaper, faster, easier to make sweatshirts. So that would translate into a cheaper production process, right? The marginal cost of making sweatshirts should be going down. And so we reflect that by shifting out to the right, or as you see down, the supply curve to S2. Okay, so now at the prevailing market price, we're again out of equilibrium. The quantity demanded didn't move. It's still here, but now the quantity supplied is greater because of the new innovation. So we end up with an excess supply or a surplus of sweatshirts. All right, well, whenever we have a surplus, it tends to drive down the price of the product. So as the price goes down, we're going to see consumers buy more, so the quantity supplied increases towards the right. At the same time, lower prices disincentivize producers, so the quantity supplied will decrease some towards the left. Eventually, supply and demand meet once again once the price has stabilized at P star 2 and the surplus of sweatshirts is gone. Okay, so here the impact of the new innovation is that we buy and sell more sweatshirts, and that sweatshirts are cheaper. So the fact that the cost of production went down for sweatshirt producers, that savings is eventually passed along, at least partly, to consumers in the form of cheaper sweatshirts.